Hello and welcome to this video on limits. So this question says prove that the limit as x approaches 0 of square root of x plus 1 minus 1 all over x is equal to 1 all over 2. Now there are about 4 methods of evaluating limit. The very first method, which is direct substitution method, must always be tested in all before the next methods are employed. So the first thing to do is to try by direct substitution method, and if the limit fails, then you can try the alternative methods. Okay, so by substitution, you set x to be equal to the point of approach, limit as x approaches 0, so simply set x to be equal to what? 0 in this case. So this simply means wherever you see x in this equation, put in the value as 0. So you're going to have square root of x plus 1 in place of x is 0 plus 1 minus 1 all over, in place of x here we have 0. So this is equal to, this becomes square root of 0 plus 1 is 1 minus 1 all over 0. And this is going to be, of course, root 1 simply gives us 1 minus 1 all over 0. And 1 minus 1 is 0 all over 0. Now this expression is called indeterminate in limits. Indeterminate. Okay, this is called indeterminate. Whenever you obtain 0 divided by 0 after using a particular approach of limit, then it is called indeterminate. This simply means that the limit has failed by the method of use. In this case, this limit has failed by direct substitution. Okay, now having found that this limit has failed by direct substitution, then we can try the remaining 3 methods. Now we have the factorization method, which is the second method, and you observe that this equation cannot be factorized. As such, we cannot use the factorization method. The third method is by the use of conjugate, where you multiply the numerator and denominator of the given equation by the conjugate. In this case, conjugate of the numerator. Now, conjugate simply means change the sign attached to the number outside the bracket. In this case, the number outside the bracket is -1. So change the sign, it becomes +1. It becomes a conjugate. So you're multiplying numerator and denominator by root x plus 1 plus 1. Okay, that becomes our conjugate. And the final method is the use of the L'Hopital's rule, where you differentiate top separately and differentiate bottom separately and obtain your result. So I am going to employ the two last methods, which is the conjugate method and the L'Hopital's rule, to solve this problem. Now, let's start by conjugate. Conjugate. The conjugate is simply by changing the sign of the function outside the square root. So I have root x plus 1. Now outside the square root I have -1. So the conjugate becomes +1. So I am multiplying top and bottom by what? This conjugate. So the equation is going to now be, now I simply have root x plus 1 minus 1 all over x. Now I am multiplying this by square root of x plus 1, now plus 1 all over square root of x plus 1 plus 1. So this is more or less you saying multiplying this whole variable by 1, because the square root of x plus 1 divided by the square root of x plus 1 simply gives us 1. Alright, so we are simply multiplying this value by 1. So it's more or less saying 2 times 1, that still remains 2. 10 times 1, that still remains 10. So whatever you're multiplying by 1 remains the same thing. So if I am multiplying this whole equation by 1, it means it still remains this whole equation. So we are mathematically correct. Alright, so let's multiply this and see. So we'll use everything here to multiply everything here. Alright, so that means it's going to now be root x plus 1 multiplying everything here, which is root x plus 1 plus 1. Again, it becomes -1 multiplying everything here, which is root x plus 1 plus 1 all over. I have x here multiplying this, which is root x plus 1 plus 1. You have this. Okay, so let's expand and see. Now, root x plus 1 multiplies root x plus 1. That simply gives us root x plus 1 all squared, since they are like terms. Okay, again, root x plus 1 multiplied by plus 1, that gives me plus root x plus 1. You have this. So we are done with expansion of this. Now we use negative 1 to expand this bracket. Negative 1 multiplies root x plus 1. That gives us negative root x plus 1. Similarly, negative 1 multiplies plus 1. That gives us negative 1 all over. Now, the mistakes most people do using the conjugate method is at the denominator. Do not expand the denominator, else it will take you back to the original question. So simply keep the denominator the way it is. X multiplies root x plus 1 plus 1, and you have this. Now, this is going to be equal to, observe, root x plus 1 all squared. Square cancels the square root, so I'm left with what? X plus 1. Similarly, this is root x plus 1 minus root x plus 1. So these two cancels out. So I am left with what? Negative 1, which is this. Now this divides by x into root x plus 1 plus 1. So once again, do not expand the denominator. So let's see where this leads us to. Now I have, observe, from the numerator, 1 minus 1 is off, that's 0. So you're left with what? X at the numerator. All over your denominator remains x multiplies root x plus 1 plus 1, and you have this. Now you observe that from here, x can easily cancel x. So which means at the numerator, you have just 1 left, all over root x plus 1 plus 1. Now you can put in your limit. So that means what you're actually looking for now becomes the limit as x approaches 0 of this function, 1 all over root x plus 1 plus 1. So you simply set x to be equal to 0. So this is now going to be 1 all over the square root. Wherever you see x, put in the value as 0. So it becomes x plus 1, that is 0 plus 1 plus 1. And this is equal to 1 all over the square root of 0 plus 1, of course, is 1 plus 1. Okay. Alright, so this is going to be equal to 1 all over square root of 1 remains 1. Put down your plus 1, and that's equal to 1 all over 2 proved. Alright, so this is by the use of the conjugate method. Now, let's try the L'Hopital's rule and see if we are still going to obtain the same result. Okay, now by L'Hopital's rule, okay, first of all, let's rewrite this equation a little bit. So this term in the square root can also be written as x plus 1 to the power of 1 all over 2 minus 1 all over x. So this is how you can also write this term in the square root. Now, by L'Hopital's rule, the rule simply states differentiate the numerator separately and differentiate the denominator separately, then impute your limits. Okay, so which means I am not going to be employing quotient rule of differentiation here simply because I have two terms dividing. No. By L'Hopital's rule, differentiate the top separately, differentiate the bottom separately, just like you will carry out your normal derivative. So let's do this and see. Now you're going to have limits as x approaches 0. If I differentiate x plus 1 to the power of 1 over 2, first thing to do is use this power 1 over 2. Okay, use the power 1 all over 2 to multiply this function x plus 1. Then subtract 1 from the power. So it becomes 1 all over 2 minus 1, just like you carry out your normal derivative. Again, multiply by the derivative of the function that contains x in the bracket. So x raised to the power of 1, its derivative is simply what? 1. Minus, if I differentiate 1, I will simply have 0. All over, if I differentiate x, I will simply have 1. You have this. So this is going to be equal to 1 all over 2 into, I have x plus 1, so into x plus 1. Now, 1 over 2 minus 1 simply gives us negative 1 all over 2. So this becomes my function. So therefore, it becomes limit as x approaches 0 of 1 all over 2 into, of course, if you divide this by 1, If we divide it by 1, it's still going to give us this. Alright. So into x plus 1 to the power of negative 1 all over 2. Now we put in the value of x as what? 0, the point of approach. And this is going to be equal to 1 all over 2 into, in place of x is now 0. So you have 0 plus 1 to the power of negative 1 all over 2. So this is going to be equal to 1 all over 2 into 0 plus 1 remains 1 to the power of negative 1 all over 2. And of course, 1 to the power of negative 1 over 2 remains 1. So you simply have 1 all over 2 multiplied by 1, which still remains 1 all over 2. So also from L'Hopital's rule, the derivation or the proof of that function remains 1 all over 2. Alright guys, so that's it on that particular question. I will see you in the next video with more amazing questions on limits. Please do well to like our videos, share to your friends, comment nicely, and if you're new to the channel, do well to subscribe. I will see you in the next video. Thanks.